Students, in this lecture, we will start to solve the problems of exercise number 2.2. Okay. In the first question, find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1 and x is equal to 2. So what we do? We have to put the values of x in place of x. So here, first of all, we have to take this polynomial is equal to px because this is the polynomial in x. So let px is equal to 5x minus 4x square plus 3. Now we put 0 in place of x. So p0 is equal to 5 into 0 minus 4 into 0 square plus 3. So p0 is equal to 5 into 0, that is 0, minus 4 into 0 square, that is 0, 4 into 0 minus 0 plus 3. So p0 is equal to 3. This will be our answer. Clear? Now in the second part we have to put x is equal to minus 1. So again we will take px is equal to 5x minus 4x square plus 3, then p minus 1 is equal to 5 into minus 1 minus 4 into minus 1 whole square plus 3. Now p minus 1 is equal to 5 into minus 1, that is minus 5, okay, minus 1 to the power 2, minus 1 into minus 1, that is 1, then 4 into 1, 4 and minus 4 plus 3. Again p minus 1 is equal to minus 5 minus 4, that is minus 9 plus 3. So p minus 1 is equal to minus 9 plus 3, that is minus 6. So it will be our answer. In the last part we have to put x is equal to 2. So again let px is equal to 5x minus 4x square plus 3, then put x is equal to 2. So p2 is equal to 5 into 2 minus 4 into 2 square plus 3. Again p2 is equal to 5 into 2, that is 10, minus 2 2s are 4, 4 into 4, 16 plus 3. So p2 is equal to 10 plus 3, that is 13 minus 16. So our p2 is equal to minus 3. It is the answer. So here we end our question number 1. Now we proceed to the question number 2. Students, here we have question number 2. Find p0, p1 and p2 for each of the following polynomials. In this question we have given py is equal to y square minus y plus 1. So here we have to put y is equal to 0, y is equal to 1 and y is equal to 2. So when first p0 is equal to 0 square minus 0 plus 1, okay, is equal to 0 minus 0 plus 1. So p0 is equal to 1. Second, p1 is equal to 1 square minus 1 plus 1, that is 1 minus 1 plus 1, 1 cancel. So p1 is equal to 1. Similarly p2 is equal to, again in place of y we will put 2, so 2 square minus 2 plus 1, that is 4 minus 2 plus 1 is equal to, so p2 is equal to 4 minus 2, that is 2 plus 1, 3. So these are the three values at y is equal to 0, y is equal to 1 and y is equal to 2. Similarly we will do question number second, fourth part. It is given px is equal to x minus 1, x plus 1. That means we have to put the values x is equal to 0, x is equal to 1 and x is equal to 2. Okay. When x is equal to 0, then we put 0 in place of x. So here 0 minus 1 and 0 plus 1. So what we get? minus 1 into 1, that is minus 1. Okay, so P0 is equal to minus 1. B, here P1 is equal to 1 minus 1 and 1 plus 1. So 1 minus 1, that is 0, into 1 plus 1, 2, that is 0 into 2, 0. Third thing, P2 is equal to 2 minus 1 and 2 plus 1. So what we get, 2 minus 1, that is 1, into 2 plus 1, that is 3, that is 3, means P2 is equal to 3. So remaining 2 questions you will do yourself. We will proceed to the third question. So students, our third question is, verify whether the following are zeros of the polynomial indicated against them. That means the value of x which is indicated against the polynomial px is the zero of this polynomial or not. We have to check it. So what we do? We will put this value of x minus 1 upon 3 in this polynomial, and after solving, if we get 0, then we can say the given value of x is the zero of the polynomial. Okay, so we will write p minus 1 upon 3, that is this minus 1 upon 3 we will put in place of x, is equal to 3 into minus 1 upon 3 plus 1, 3 cancel, here minus 1 plus 1 is equal to 0. Since we get 0, the value of p minus 1 upon 3, hence we can say that x is equal to minus 1 upon 3 is the 0 of px. Clear, students? Now in the sixth part of this question, what we have to do? We have to put the value of x, that is minus m upon l, in place of x. So p minus m upon l is equal to l into minus m upon l plus m. Here also l cancel, here minus m plus m is equal to 0. Again we get 0. So we can write, hence x is equal to minus m upon l is the 0 of px. Clear? Now in the seventh part, again we will do same thing. We will do here 2 numbers. That means first of all we will put minus 1 upon root 3 in place of x, and secondly 2 upon root 3 in place of x. So when x is equal to minus 1 upon root 3, then 3 into minus 1 upon root 3 whole square minus 1, 3 into minus 1 upon root 3 into minus 1 upon root 3, that is 1 upon 3, 1 upon 3 minus 1, 3 cancel, that is 1 minus 1 is equal to 0. Clear? Here we write x is equal to minus 1 upon root 3 is the 0 of px. Similarly, we will put 2 upon root 3 in place of x, that is 3 into 2 upon root 3 whole square minus 1. Clear? Here 3 into 4 upon 3 minus 1, 3 cancel, here 4 minus 1 is equal to 3. Since this 3 is not equal to 0, so we will write x is equal to 2 upon root 3 is not the 0 of px. Clear, students? So we will proceed to the next question. Students, now we do question number 4, and the question number 4 is, find the 0 of the polynomial in each case of the following. Okay. So, we have to find the 0 of the given polynomial. So, what we have to do? We have to put the given polynomial px equal to 0. Okay, for finding the zeros. So, for 0, px is equal to 0. Okay, and px is equal to x plus 5, it is given, is equal to 0. This implies x is equal to minus 5. So, x is equal to minus 5 is the 0 of the polynomial px is equal to x plus 5. Clear? Similarly, in this case, again we put for 0, px must be equal to 0. That means, what is the value of px? It is x minus 5. So, x minus 5 is equal to 0. This implies x is equal to 5. This is the 0 of this px. Similarly here, again we will write for 0, px must be equal to 0. This implies what we do? This px, value of px is equal to 3x minus 2. So 3x minus 2 is equal to 0. This implies 3x is equal to 2, and this implies x is equal to 2 upon 3. This 2 upon 3 is the 0 of this px. Clear? Similarly, we will do in the seventh part. Px is equal to cx plus d, where c is not equal to 0 and c, d are real numbers. Okay. So again we will put for 0, px is equal to 0. This implies cx plus d is equal to 0. So cx is equal to minus d and x is equal to minus dy c. This is the 0 of the given polynomial px. Now we proceed to the next topic. So pause the video to be noted down.